Oh, by the way, can you hear the recording in progress voice?
Yeah.
Yeah, okay, good. Yes. Okay, then the next one is log x base a power 4 equals to c. Okay, what do you want? You want to solve for x, basically. Oh, make x the subject in terms of a and c. How? How? Okay, I'm gonna save some time. I'm gonna make use of the trick. You know this trick? Log, I think I went through before. Log, okay, don't use a. P base q is just 1 over log q base p.
Okay.
The proof for this is log p base q is really just, if you use change of base formula, log p goes on top, q goes below, choose a correct base, choose base p. Yeah, choose base p. So the numerator here is log p base p, which is just 1. Then you're left with 1 over log q base p. Okay, the trick here is you got p on top, q below. It just becomes 1 over p below, q on top. You swap the p and q. Swap the p and q. But it becomes a 1 over. Is that clear?
Okay.
So that's the trick. So over here, I see there's a 1 over x. So I'm just going to copy and paste the equation. But I'll replace the 1 over x with x power negative 1. Then I will bring down the negative 1. So I get negative of log x base root a. Everything else copy paste. Okay, then now I notice everyone has an x. It's just that the base is different. Can I combine them together? So I get I don't know, like these two add together, then I get log of a times a square base x. Sorry, log x base a times a square. Is that such a rule? Is there such a rule?
No.
No such rule, right? Exactly. Good. So you're not confused. Well done. The rule only works when the base is the same. So what should you do? Yes, correct. Change the base by using the trick. So it's 1 over log a base x, 1 over log a square base x, 1 over log a power 4 base x equals c. Take note, the c never flip. It's only a special logarithm identity. That's why this becomes 1 over. I didn't try to reciprocal the entire equation. I'm not flipping the entire equation around. No. I'm just using log identity. So likewise here, negative 1 over log root a base x.
Yeah.
Actually, is this useful? I'm also not sure. Let me think a bit. Might be a bit more difficult than I thought. Let me think. Because now that I have a bunch of fractions added together, I need to make sure the denominator is the same before I can add them together. But if I try to make them the same, I have to multiply the logarithms. Unless there's another way. Yes, there is another way. Okay, we can continue modifying this. Yeah, remember the intuition I have now is I want to add the fractions together. Okay, I want to bring all the x's close together. So I want to add the fractions together, combine. In order to do so, I need to make the denominators the same. So I notice, they all look a bit different. If you try how some people will add fractions together, like for example, 1 over 3 plus 1 over 5 plus 1 over 7 would be to combine it into 3 times 5 times 7, right? You get 5 times 7 plus 3 times 7 plus 3 times 5. Here, if you try to do that, that would be a very horrible idea. Why? Because the 3, the 5, the 7 represents log something, log something, log something, log something. If you multiply logarithms together, let's say log p base q plus log a base b, or let's say I make the base the same, both base q. Sorry, not plus, I want multiplication. Is it equals to log p times a base q?
No.
No, right? It's not equal. So there are no special identities when you try to multiply logarithms together. So that's why we don't do this thing, where we multiply all the denominators together. We try to avoid that. Oh, by the way, just to make my life easy, I'm gonna bring the minus on top. You agree, right? If I just bring the minus on top, it's the same thing. -1 divided by log.
Yep.
Can now? Okay, good. So don't multiply. Instead, you should try to use logarithm rules. So over here, what are you writing? Sorry, what were you writing?
No, I agree with this.
Oh yeah, correct. Let me just modify my screen a bit. Okay, is it still okay? Is it still clear?
Yeah.
Okay, good. Let's continue. So here, square root is power what?
Half.
So I can have a power half, right? What can I do with the half? Bring in front, yes. So now I get a half in front. What's 1 over half?
Isn't it just
2,
2?
exactly. So now I can change it. I skip a step, I multiply by 2. Do you understand what's going on here? Is it too
Okay.
fast? Can
I
the
understand.
1 over half, the 2 go on top. Is that clear?
Yeah.
Can. Okay. Next one, I see log a base x, can't really do much with it. Here, the next one, what should I do? Log a square base x, what should I do?
2 log xa.
A base x, good. Same thing for the last guy, 4 log a base x. Then you start to notice, they start to look similar, right?
Yeah.
So common denominator. There's a 1, there's a 1, there's a 2, there's a 4. What's the LCM of 1124?
4.
Just 4, right? So we're gonna get 4 times of log a base x. How do you get from a 1 to a 4? Times 4 on top and bottom.
Minus
Then
8.
you get a -8. Next one. Times 4 times 4, so plus 4. Next one.
Plus
Times 2 times 2, so plus 2. Next one. Just plus 1.
plus 1.
Equals C. Okay. Oops. This is blocking my space. Wait. Let me modify this. Okay, good. Then continue. So can you calculate this for me?
-1.
-1. Okay. Over 4 log a base x. By now you know how to solve for x already, right? Do I need to continue?
Wait, what's the question?
Make x the subject, or find x in terms of a and c.
Oh, okay.
Can already, right? Don't need to continue? Or you want me to go through? I'll just go through.
Yeah.
So denominator involves the x. So you just multiply over, divide, bring over becomes times. So c times 4, which is 4c, multiply by log a base x. Yeah. Then you want x on its own, but it's trapped inside the log. And then there's a 4c multiplied to it. So I just bring the 4c over. So I get log a base x equals to -1 over 4c. Then if you want to bring the base over, you will push the -1 over 4c on top. So it becomes x to the power of -1 over 4c. Here I would like to I'll make x a subject. In other words, I want x power 1 as a subject. How do I go from -1 over 4c into 1?
Times -4c.
Good. If you times -4c, that's the same as raising the right hand side to the power of -4c. So on the right hand side, you also have to do the same thing. Raise to the power of -4c. Okay? Then therefore you get x equals to a power -4c. You can flip it around, then you get 1 over a power 4c. If you like positive indices. I don't know why O-levels love to test on positive indices. No point. I'm sure you know this. Can? Okay, moving on. So what is the next question? 14 done already, now 15. What happened? You stop halfway. You are almost there. What is 15 asking? 15 is asking you to find B in terms of A. Yeah, so basically there is a hidden hidden, what do you call it, quadratic equation here. You can substitute the log a base b with an x. Right, then you get 2 over x plus 4 times x equals to 9. Can you see that?
Oh.
Then you just times x, then you get quadratic equation, blah, 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 solve for x, and then you can get substitute the capital X back with log a base b, and then you just bring the b over, so on and so forth. Do I need to go through?
No.
Don't need, okay, good. Just an extra question. Let me find the question first. Hold on a second. Hold on a second. Oh, what's that arrow?
Oh.
I don't know. Okay. What is that question I wanted you to try? Where is it? Not this one. Sorry, give me a second. Okay, found it. Okay, let's give an extra question. Something interesting, also on quadratic equations. So over here we got, I merely write down the question. You want to factorize the following. Factorize 8x squared minus 10xy plus 3y squared. Try. How?
Oh, okay.
Factorize. This is not. Oh, you're trying to solve it. Okay.
Wait.
Solve
What?
means equals 0, then you solve for x. But here it involves x and y, so you can't really solve it, at least not for A max. H2 maybe. But here is factorizing. You need to factor out common factor. How?
Can you do like wait, let me think.
Have you been taught this? Draw a table. Like.
Yeah, but I forgot.
Okay. Yeah. Usually people will forget this. But basically you just need to guess and check. What are two factors that multiply together to give you 8x squared? There's many possibilities. Let me just review the answer straight away. 2x and 4x, okay? So now that you have 2x and 4x, what you want? You want to look at your 3y squared. Then you need to consider two numbers multiplied together that will give you 3y squared. Could be 3 and y squared. Could be -3 negative y squared. Could also be, what is it? Could be 3y and y, or -3y and -y. All these possibilities you need to cross. Then you can see if you get the correct answer. So one way to figure out which is the correct option is to okay, and after you try, let's just say let's say for example I pick I don't know 3y and -3y and wait -3 and -y squared. Yes, it's correct already. Yeah, correct. That's the answer already. Okay, but let's say if you did this, what you want to check is 2x times -y squared is -2xy squared. Then the other option will be -3 times 4x, which is -12x. Then you have to add them together, plus, to see if it's -10xy. So in this case, it doesn't work. That's why you have to try the other option. Eventually, if you do guess and check long enough, you will get you will come to the conclusion that it should be a -y and -3y. Let's see if it works. 4x times -y minus 4xy. 2x times -3y minus 6xy. Add them together, do you get to -10xy? Yes. Okay, good. Another way that you could have done this instead of drawing a table is to think of -10xy as being the sum of two numbers.
That's what I was thinking to do.
Yeah, you need to.
Then is it like you take out, then it will be like the same thing, then like
Yeah, you're supposed to eventually, if you're doing that, you're supposed to realize that minus 10xy is really the same as minus 4xy minus 6xy.
Yeah.
Right? Then you can factor out the common factor. Yes. So here there's a common factor of 4x. Whoops, let me get rid of that. 4x, then you get a 4 times 2 is 8, right? So 2 here, x there, minus away y. Then over here, do you see a common factor? Yes, there is a negative 3y, right? Negative 3y. Yeah, correct. Eh? Oh, you should factor out extra negative as well.
Yeah, I just realized, so that it will be the same. Okay.
Yes. Then you get the same factor, common factor 2x minus y. Then you factor out 2x minus y. You're left with 4x minus 3y. Okay, of course, left times right, right times left is the same. You can swap them around. Okay, that is your first step. This is the part A. Part B asks you, hence find the possible values of x and y if you got this expression on the left-hand side. Expression means you don't have equal sign. Expression. But now I change it to an equation. Equals to 0. The question is actually asking you find possible values of x over y. Listen carefully, x over y, not x itself, not y itself, but rather x over y. How would you do it? Very simple. You already learned you already part A factorize it. So yes. Just take the factored form and equal to 0. Got something times something equals 0. So that means your first guy equals to 0. Or second guy equals 0. Then you want to solve for x and x over y. So you can just maybe do this for the left-hand side. Bring the minus y over. You get 0 plus y, which is y. Divide by y. Don't forget the 2 times in front. Get a 1. Half. Correct. How about the other guy? 4x equals 3y. X over y equals 3 over 4. Yeah. Good. That's one way you can do it. Let's say there wasn't a part A, okay? Let's say that there wasn't a part A. Then I give you this equation straight away. I ask you to solve for x over y. Do you think it's possible?
Can I use quadratic?
Yes, you can. Yes, you can.
And, like I just put in like, yeah, like, you know.
But what's the coefficients here? Is it
8
equals to 8
minus 10y, then 3y squared?
Yes, you can actually. You can. Let's see if it works. So we solve for x, negative b negative y plus minus square root of p squared minus 4 times a times c over 2 times a. This is actually not in A max because here it involves y already. This is only taught in H2 max. Okay, solving a quadratic equation where the coefficients involve variables. Okay, let's just simplify this. See if we get our same answer. We'll get 10y plus minus square root of what? This one need to simplify. 100y squared. 4 times 8 is 4 times 8 times 3. Let me double check with my calculator. Minus 96y squared. Simplify, you get a 4y squared. But you have a square root, so it becomes a 2y. Is that okay?
Mm-hmm.
Over 16. Then it becomes 10y minus 2y over 16. Or x equals 10y plus 2y over 16. Which is equal to 8y over 16. Which is y over 2. Or half y. Then you can just divide by y on both sides. You get x over y equal to half. Same answer. Other guy? Yeah. 16x equals 12y.
Wait, I made some mistake.
Oh
yeah. Okay.
12 over 16 now. Yeah. Then you get what is this? This is 3 over 4. Yep. So what you realize is that you're solving for x over y, right? So doesn't that mean that it's a quadratic equation in terms of x over y? Do you get what I mean? Like something square plus something plus a constant, but here it's x over y, x over y. got some coefficient in front and some constant.
Okay.
So how can we get it into this format? Let me show you a trick. Another way to solve this equation. This is using formula, quadratic formula. Here is another method. What if I divided throughout by y squared? What will I get? 0 divided by anything is just 0. But on the right hand side, what do you get? 8x squared over y squared minus 10xy over y squared plus 3y squared over y squared. Okay, the 10, maybe I'll just put it on top so it looks nicer. You can cancel things off, right? This, or rather, you can factorize things. Here, x squared over y squared is actually 8 times x over y bracket square. Right? Then here, y and y squared can cancel off. You're left with 10 times x over y. Then the last guy, y squared and y squared cancel off. You're left with a 3. Do you see that this is a quadratic equation in terms of x over y?
Yeah.
Yeah. Then you get 8x squared minus 10x plus 3 equals 0. Then you can just solve using quadratic formula or whatever other method. Okay? Yeah, just something interesting to share. Sometimes you will have hidden quadratic equations in this format. Can?
Okay.
Yeah, that's just an extra question. Okay, moving on. So that is your one, what is it? 7.3 done. Let's move on to 7.4. The other worksheet you sent me. Over here. Exercise 7.4. Still under the log 1.1. Something went wrong here. Okay. I think you had a careless mistake or something. Over here, I don't know what happened. How come the 3 and 2 power negative 2 converts the 21 into a 28? Here's my suspect. Here's what I suspect. Somehow your 3 turned into negative 3. Somehow your 2 power negative 2 is 1 over 4. It turns into a minus 4. Then you got minus 3 and minus 4 become minus 7. So you bring over become plus 7. I have no idea what's going on.
Wait, this was a question.
Yeah, yes. Wait, let me just double check the question. This is question 4 part. Let me read the question. Let's see. Question 4 part C. By expressing each of the following equations in the form a power x equal to b, where a and b are real numbers, take logarithms to solve for x. We're trying to solve for x. 21.
Wait, what is this? What is this number?
21 divided by 3 divided by 2 power negative 2. Let me see what that number is. You can use a calculator to check. Oh, by the way, I strongly do not recommend you to use the divide symbol. Because divide can be a bit confusing. When you say 21 divided by 3 divided by 2 power negative 2, do you mean the brackets are over here? Or do you mean the brackets are over here? Okay, do you get what I'm saying? Like, let me show you.
If like A divided by B over C versus A divided over B divided by C. Is it?
Yes, correct. Yes. There are different ideas, right?
Actually, what's the difference? I know that is different, but what's the...
Okay, let me show you. Over here, if you have A over B over C, how you would write it in terms of the divide symbol would be A divided by bracket B divided by C. Here, the other one will be A divided by B, bracket, then divide by C. If you never put the brackets, it's a bit confusing. No, it's misleading. It doesn't even make sense. Here, A over B times C, you can times C at the top and bottom, right?
Yeah.
So you end up bringing the C on top. So it's A times C over B. But the other guy, if you times B on both sides, the B cancel off at the numerator. But the essentially, yes, correct. The B essentially goes down. So they are totally different.
I think I did this. Then I typed this into the calculator. Then I get 28.
Oh, is it? I mean, oh yes, it's correct. Oh yeah. But it is 28. Let me see. Was I not thinking correctly? Let me see if your answer is correct. This is multiplication. Oh, right. Sorry. Oh, I think your answer is correct. Right. It is correct. Let me make a correction. Sorry, I finally understand what you're doing. Yes, this is all multiplication, right? 3 power x times 3 times 2 power x times 2 power negative 2. So you just multiply these two together, then you divide over. 21 over 3 times 2 power negative 2. It's still 28. Okay. I'm so sorry. I marked wrongly. This is correct. This one you take log base 6. Let me see the value. Log 28 over log 6. 1.85973. Round off 3SF 1.86. Correct. Okay, sorry, you are correct. I am wrong. I finally understand what you're thinking about. Okay, can. Okay, I marked wrongly. I'm so sorry. Let's move on. What was the other thing that I marked wrongly? Or over here. Okay, it's not a mistake, but there's a faster way to do it, which is to times y on both sides. Then you can immediately get to this equation. Can you see? So you get y times y plus 12y power negative 1 minus 7 equals 0. Then 0 times y. So it just becomes a 0. But y, if you multiply throughout, what do you get? Y times y square.
Y square.
Y times 12, y power negative 1 is just plus 12. Then minus 7y.
Oh, why didn't I do that?
Yeah, a bit faster. But yeah, you did a lot of steps, but eventually you get the same answer, so you get the correct answer, so it's fine.
Okay.
Moving on. Here, let me see. Okay, you lost an answer because you divided by y. You see, y cubed become y square become y no more y. Means you're dividing by y, right? You cannot do that because you will lose a solution y equals to 0. What you're doing is you're dividing by 0, possibly.
Then like that, can I like factorize out y?
Yes, correct. You should factor out the y. Yes.
Oh, okay.
Okay, I'll leave that to you. Moving on. This one went through in class already. Don't need to go through. Part C. Okay, what you did is correct, but a bit long-winded.
Okay.
You should just ln straight away. Let me show you.
Ln both sides.
Yes, correct. The x times e power x squared equals to ln 30 e power negative x. Then you can see straight away there's a power 2 you can bring down. So 2 ln of x e power x. This one also can split up ln 30 plus ln e power negative x. Then you can see ln and e cancel off. So you simplify right hand side to ln 30. Add on negative x, so minus x. But the left hand side, you have a product x times e power x. So it's just 2, there's an invisible pair of brackets here. ln x plus ln e power x. If you're even faster, you can also see ln and e cancel off. Straight away, simplify it down to 2 bracket ln x plus x equals ln 30 minus x. Then now what do you have? You want ln x on the left hand side, right? So you see ln x here. You can leave it alone also 2, but you need to times that 2 over. Wait, actually no. Maybe we divide by 2 on both sides. So we get ln x plus x equals to ln 30 divided by 2 minus x over 2. Then you can now make ln x a subject. Plus x bring over become minus x. Everything else remains. But here you can simplify a bit more. Minus half a x minus 1x. is minus 3 over 2x. Copy down the ln 30 over 2. I think it's a little bit faster.
Okay.
Yeah. Okay, so the trick here is that whenever you see like multiplication and you see a power, you take ln on both sides. ln helps you to convert a product into a sum. It also helps you to bring the convert a power into multiplication. So it sort of brings it down one level, right? From addition, multiplication, and then exponentiation. It helps you to bring it down one level, bring down one level. You see the pattern?
Yeah.
Power becomes multiplication. Multiplication becomes addition. So on and so forth. Yeah. Likewise for division and subtraction. Same pattern. Okay, Ken. Moving on. Anything else that's wrong? Here careless mistake should be a 5. 32 is 2 power 5, not 6.
Oh.
Yeah. Yeah, just a careless mistake, but the rest is, I think you know how to solve. I also gave you the solution here already. So I will leave that to you to read. That's all for the homework. Ken?
Okay.
New topic. Moving on. Have you watched the video already?
Yeah. Exponential graph.
Yeah, basically very simple. Just memorize only. So it looks like this. Y equals a power x. Or the other case. Y equals a power x. This one is when a is more than 1. This is the case where 0 less than a less than 1. Can you have a to be negative?
No.
Base as negative? Cannot. Maybe you can, but if you try to plot the points, like for example, y equal negative 2 power x, you can plot a bunch of points. X equal minus 10, minus 9, minus 8. You can plot all the way. Minus 2, minus 1, 0, 1. You realize that the graph is very erratic, very, very weird. It just keeps on going negative, positive, negative, positive, negative, positive. You go up, down, up, down, up, down, up, down.
Okay.
Yeah. So that's why we try not to deal with this. We box it up and we ignore it because it's very confusing to deal with.
Nice.
So we only focus on the easy case where a is positive, or where it's a fraction less than 1, or if it's more than 1. What happens if a is exactly equal to 1?
Won't it just be like a straight line?
Yes, it's just a horizontal line y equals to 1. So also very boring. This one boring, so we don't look at it. This one, we also ignore this case.
Okay.
Boring. This one is too difficult. Too difficult or too boring, we ignore. The one that's just nice in between, then it's inside the syllables. A more than 1, 0 less than a less than 1. So this a doesn't just have to be a, it is usually e. Do you know where you can get to see e?
Wait, can you say that again?
Where do you get to see the letter e?
No,
Other than
what you say before that?
What did I say before that? Oh,
Yeah.
I said, the letter a here is representing any number, right? So I'm saying that usually it can also be the letter e, which is the on your calculator is 2.71828. 1828. Is that clear? Right? You know this number, huh? You know how to access that number on the calculator?
Yeah.
The purple, the pinkish, reddish, purple color beside the pi. E 2.71828. Okay, so a equals to e, which is approximately 2.71828, is one example of a. Then my question now is, do you know in what context this e will come up? In what context does this e will appear?
Wait.
Like let's say y equals e power x. When would you see this?
Y equals to e power x.
Yes.
Wait, what's the question?
In what context will you see this kind of equation? When would you use this equation? Or when you're trying.
What do you mean?
Okay, maybe that question is quite confusing. Any real what I mean is, do you know of any real world application to this y equals e power x? No, okay, then okay, that's why we have this lesson today. So do you know something called compound interest?
Oh yeah, okay.
So in compound interest, the formula goes like this, right?
I forgot.
A equals to P times 1 plus R over 100 to the power of N. This is quite important. Banks always, in the real world, everybody uses compound interest. Nobody uses simple interest. How did this formula come about? Let's say you have a savings account. Oh, by the way, the best savings account now is, I feel, Standard Chartered. Oh, it's not like
Why?
promotion. Because it has the highest interest rate and it is covered by the MAS. If you store up to $20,000 and if the bank suddenly closes down, they will pay you back.
What's the interest rate?
I think it's very little. It's just 0.5% or something.
Oh, long.
All the banks are very low. So let's
Yeah.
just say that we have this percentage being 0.5%, which is actually just 0.5 over 100, which is 0.005. Very little amount. Here in this formula, capital R is 0.5. Or the over 100 means percent. The percent is the over 100. It's the divide by 100. The 100 over here. Then how did this formula come about? How we do it is we start off with a table like this. Let's call this N. Oh, sorry, I should mention. This one is 0.5% interest per annum per year. So let's say that we compound it monthly. What does that mean? It means that I'll just give a full example first. Okay, I should put an example here. You put in $10,000 into your bank account. We call it the principal P. Then they say the interest is compounded monthly, and let's say you store it inside there for a time period of I don't know, 2 years. Then after 2 years, how much money will you earn? Oh, you're writing already. Let me see. Yes, correct. Because this is compounded monthly, but here is per year, you need to scale it. So per month, what is the percentage? It's actually 0.5 divided by 12, which is even smaller. 1 over 24%. How much is that? That's just 0.0416 recurring. Okay, then if you put for 2 years, how many months is that? That's just 24 months. Yes, correct. Okay, that's the answer already. But let's see how we can derive this. 10,000 multiplied by 1 plus 1 over 24 over 100 raised to the power of 24. Here, if we start off with like let's say N represents 1, then what is the amount of money you have? Let's say A. It will simply be the original amount you put in. Then you add on the interest, which is how much? 0.5%. So 0.5 over 100. Or rather, if I write it as decimal, 0.005 times the original 10,000. You can factor out the 10,000, right? Then you get 1 plus 0.005. Oh, sorry, that's not correct. It shouldn't be 0.5% anymore. It should be the 1 over 24%, the 0.416. 0.0416. I'll just use the rounded off value. Then the next year, when N goes to 2, your interest will earn money for you. Basically, this is the amount you currently have in your bank. You have to add on the interest. So we're gonna copy down whatever was from the month before. N represents number of months. Sorry, forgot to mention that. So at the end of 2 months, how much money will be in your bank? the amount from before, but you have to add on the interest you earn, which is the exact same amount, but you multiply by the interest percentage. Now, if you multiply in, what do you get? You'll end up with, if you try to simplify this, you'll end up with, okay, this one, let me just move my screen. I need more space. I'll put it side by side so it looks nicer. This will be equals to, this part here will be equal to what? 10,000, but you multiply in, so you get 0.0416 plus 0.0416 power 2. Okay, plus the original amount. Then you realize that there is a 10,000 in front, so you can factor out the 10,000. Then you'll end up with 1 plus 0.0416. Did I do something wrongly? Let me double check. Right. Sorry. Let me try again. I don't need to do so much work. Okay, the common factor here and here, can you see? There's an invisible times 1 here. So there's a common factor of 10,000 multiplied by 1 plus 0.0416. Do you see that common factor? Then you can factor out. Once you factor out, what are you left with? You're left with this, which is your original amount after end of 1 month, but you now have to add on the interest. But after you factor out this common factor, you're left with pink color 1 plus that interest from before. From the right. Close the bracket. What else do you notice? Here is 1 plus 0.0416. There is also the same quantity. So another nicer way to write this would be 1 plus 0.0416 to the power of. So that's after the second month, then power 2. Then you can continue the pattern. If you go on to number 3, you just get the original amount, but you add on the interest. The original amount after the end of the second month, but then you have to add on the interest, which means you take that amount, you multiply by 0.0416. Then you repeat the process. Factor out the 10,000, bracket 1 plus 0.0416 power 2. You're left with 1 plus, where do you get the 1 from? It's from here. That's a times 1, invisible times 1. Then you add on the 0.0416. If I just change the color. Then what do you notice? Here power 2, here power 1. Combined together is power 3. So in general, you start to see the pattern already. When it's 1, there's an invisible power 1. When it's 2, there's a power 2. When it's a 3, there's a power 3. So in general, if it's the nth year, or let's say capital N year, what's the formula? 10,000 multiplied by 1 plus 0.0416 to the power of n. Sorry, not nth year, I mean the nth month. Is this okay?
Yeah.
So that's why that's how the formula came about. You don't just memorize it. You try to understand where it came about. 1 plus. Why is there a 1 plus? It's because when you're trying to factor out, there's a times 1 here. Okay. Yeah. Okay. Anyways, so that is when you're compounding monthly. But what if you change it to per day? Let's say instead of per month, you change it to per day. What would you need to do?
Wait, say that again.
Okay, let's just write down the amount for the original first. Whatever you wrote down just now, it was 1 plus 0, 1 over 24%. So divided by 100, raised to the power of number of compounding periods, which is 24. Now my question is, what if I change the problem from this to the exact same situation, but I change it to, instead of monthly, I change it to per day?
Oh,
Do you still divide by 12? No, you have to divide by 12 times
30.
Let's assume that's 30 days in 1 month. Could be 31, could be 29.
yeah.
Let's just assume it's
true.
30. Assume 30 days. Assume 30 days every month. We will undercount it, but never mind. It's close enough. Then what will you get? It's not 1 over 24 anymore. It's 1 over 720, right?
And this also to the power of 720.
Yes. Maybe I'll just write, okay, just change accordingly. Then since I talked about day already, what if we just compound even more? What if we just compound even more? Instead of per day, now let's change to per hour. What would be the value now? Let's just assume 1 day has 24 hours. I think that's a reasonable assumption.
Wait, so now the is compounded every hour.
Hour.
Oh, okay. Yeah.
Then what's the percentage now?
The bottom times 24.
Times
and
20.
One also times 24.
Yes, so 720 times 24 is what? That would be 17280. Yes, the power number, here the power is referring to number of times that you compound. So it's also 17280. Yeah. Is that correct? Did I calculate wrongly? Is it also 17280? Here I put for 1 year, sorry, I put for 2 years, so that means that I have 24 months. Okay, sorry, I forgot to account for the number of years. Here 24 months is actually, you also need to convert into the number of days, right? Because if you compound per day, how many days are there? Is it still 720 days? Is it correct? Is it actually let me calculate that. Oh, it's correct. Oh, you just have to multiply this by 30. Sorry. You're correct. Yes, 720 days. Okay, so basically, the pattern I'm trying to get you to see is that here, this power, this value, if you can you try keying it into your calculator? What do you get?
This value.
This okay, yes. This entire value and that entire value.
Oh, okay.
How many hours is that? 24. Let's hope the calculator can handle this.
Oh, wow, it's basically like the same thing.
Yes. Okay. Then now I want you to what I got on my calculator was 10,100.50097. The other guy, let me see. What do you get? 17280 times 100. A bit more, So you realize that even though you compound more and more times, right? More frequently from per day to per hour, the amount that increases doesn't change much. So that means that there's a sort of limit to it, right? There's a maximum value that you will approach. There's a maximum boundary. It won't increase beyond this boundary. So now I want you to take this guy, you divide by 10,000. Divide by the principal, divide by 10,000. What do you get? Can you try? This one.
Okay. You get 1.0100500097.
Same thing over here, divide by 10,000. What do you get?
1.010050164.
Oh, let me try on my own calculator. Yeah. So now I want you to try this instead. If you take e to the power of, do you know what's e? I need to show you. Can then you raise it to the power of the rate. Let's say we try the 1/720. Is it correct? Am I doing this correctly? That's not right. Let me think a bit. This isn't right. That doesn't seem right. Let me think a little bit. Okay, so basically, right, what you should realize is that eventually this, when I ask you to divide by 10,000, actually, I'm just trying to get you to calculate this value here and that value there. Okay, right? Because here you times 10,000, you divide again, you get back to this exponential. What I'm trying to get you to see is that eventually, right, if you follow the pattern, right, what's going on is there's this 1/1 plus, sorry, 1 plus 1/n to the power of n pattern. Can you see that? If you bring this down, or maybe 100 times.
Wait, say again.
What I'm trying to get you to see is that this part here and this part here, it just follows this pattern, right? Where n is 720, or n is 17,280. As the n gets larger and larger, meaning you compound more and more of that, you can do on your own. Maybe I think this one, I don't want to waste too much of your time. If you change it from per hour to per minute, or from per minute to per second, more and more frequent, you realize that the n value here, the 1728 or 720, will change to 17280, will change to an even larger value, and even larger value. So eventually it follows this pattern and the n gets larger and larger. What you realize if you do a quick experiment is that the limit of this guy as n goes to infinity. What is limit? Limit just means you consider what happens as n turns very, very big. Let's take a look at how this value will turn out to be. What this value will turn out to be. I'm going to move on to decimals already using a graphic calculator. 1 plus 1/100 times n, bracket to the power of n. Okay, let's see. Let me change screen now. Over to the screen here. Okay, we're gonna try drawing this graph. 1 plus 1 over, instead of n, we're gonna use x because that's how the calculator here works. And then if you put in 100, there's really no difference. You can actually not put the 100 there. It will still you will still get the same pattern. Then you raise it to the power of x. Did I do something wrongly? Okay. Let's say I get rid of that 100. Then let's see what happens. Okay. So you see this graph, right? As x increases, this graph value, y value will increase, right?
Yeah.
You see? Okay. So if you keep on increasing it, you realize that it grows and grows and grows until it becomes almost like a horizontal line, right?
Okay.
Then what do you notice about this value is that it's actually just getting closer and closer to y equals to e. Let me draw for you. Y equals to e.
Oh, so the asymptote is like the asymptote is
y equals to e. Okay. So what this really means is that sorry if I was too long-winded, but basically, right, compound interest, when you try to compound it more and more frequently, you will reach a maximum limit, and that limit will involve the natural number e. This natural number, 2.718281828. This guy. Okay. Okay. Good. Okay. Let me change back to my iPad screen. So maybe that divide by 100 there shouldn't be there. Can't see the pattern with a divide by 100. Okay, let me remove this 100. This will eventually be equals to E. Okay? Can? So yeah, as you increase the frequency of compounding, like compound per month, per year to per day to per hour to per minute, so on and so forth, you will eventually reach a limit. You will the formula will go from A equals to P times 1 plus R over 100 to the power of N. It will eventually convert itself into A equals to P times E to the power of R times T. This is the PERT formula. If you do financial mathematics, you will learn more about this. Okay? This is one application. Actually, you'll be seeing it right now. Hopefully, I can cover it. It is one of the practice questions. So let's, do you have the PDF log 1.1 open?
Log 1.1.
1.1.
Yeah.
Then go to exercise 7. What is it? 7.5. Okay, we'll try some questions from here. Okay, do you yeah, okay, let's just try question 1. Let's look at question 1, the basic one. On a separate diagram, sketch each of the following graphs. For part A, okay, logarithm is very simple. It's just this graph. Cut through 1, 0 as an asymptote at x equal to 0. And it just keeps on increasing. It's just increasing very slowly. Okay? How about part B? Y equals to log x base 6. There is no difference. On this one, they ask on separate diagram, right? So there is no difference. It's still the same graph. Oh, sorry, 1, 0. Still x equals 0 asymptote. Then for part B, here, when you have log x base 0.2, what happens is that the graph will look something like this, downwards. But a bit confusing, right? To just memorize a random shape. So what I like to do is to just memorize that whenever my base here is a whole number bigger than 1. So log something that's bigger than 1, or maybe a nicer notation is A, and then I say A bigger than 1, x, the graph will always look like this, 1, 0. This corresponds to this with A bigger than 1. Is that okay?
Okay.
Can. But here log, I see there's a base 0.2, which is no good. I don't understand how to draw the graph with a base that is not bigger than 1. So what I do is I do change of base. I'll change it to something, let's say base E. You can also write down ln if you like. Is 0.2 a good choice? I mean, is E a good choice? Maybe not so good, because I can't really simplify this down with log of 0.2 E. I can't simplify this log 0.2 E, 0.2 base E without a calculator. But never mind. I think log E 0.2 base E is still okay. We can calculate the value now. So this is really just 1 over ln 0.2 times ln x. What is 1 over ln 0.2?
1 over
negative 0.6213. Yes, can all?
Yep.
So here, when you have a negative in front of the lnx, you know how to draw lnx graph already. It just looks something like this. I mean, it's just another log graph. Then when you multiply by 0.6213, what happens? You're just gonna make it shorter, increase slower. Right? So there's not much difference. It's really just the same thing. It's just increasing slower. This is y equals to 0.6213 lnx. But now when you have an extra negative sign, what happens? Flip, exactly. So you just flip it upside down. But you still pass through 1, 0. Okay?
What the? Okay.
Yeah. Makes sense, right? When you have an extra negative sign, all the x that you put, all the y coordinates that you originally got, you have to multiply by -1. So you flip it upside down.
Okay.
Okay, reflect it about the x-axis. Okay, so now yeah, then that's the schedule. This is the answer already. Of course, this is just an approximation of the exact answer, which is log x base 0.2. Okay, this is the graph. Okay, next part C. Part C is like y equals to log x base 1/4. Again, it's the same graph, right? It's the same shape. It will go downwards like this, 1, 0. Nothing much to it. Okay. Can I always pass through 1, 0. Then for part D, yeah. Okay, part D already. That was, did I copy wrongly? Oh, this is part D. Okay, now it's part E. Part E is y equals LGX. What's LGX? Base 10.
Log 10.
But it doesn't matter. The graph still looks the same. Okay. Yeah.
Okay.
And then part F, also the same thing. Y equal L and X. It's still the same graph. 1, 0. But maybe if you want, you can label an extra point that it passes through that's unique to it. Like let's say E, 1. And here will be 10, 1. If you like, but honestly not needed. Not necessary. Okay, it's just this graph. Yes, but don't curve down. Make sure you keep on going upwards. Yeah,
Okay.
there's no asymptote. You don't curve and make it look horizontal. No. It keeps on increasing. It keeps on increasing. It's just increasing slower and slower. Okay, Ken, next one, question 2. pH value. You learned before acid and base, right? Acid is H plus, base is OH minus. Right, sodium hydroxide is a base. If it's aqueous, you dissolve in water. Or if it could be HCl is a hydrochloric acid. You can dissolve, so you get what? H plus and OH minus. Sorry, Cl minus. Right? Have you haven't did JC level H2 max, right? No. Okay, but basically when you move on to, if you went through the H2 max syllabus, you will have to learn about this thing called the pH scale. There is a formula which says that pH level, like you see pH 7 means natural, pH 14 means basic, pH 1 or 2 means acidic, right? What it actually means is this formula here. Negative log base 10 of square bracket H plus, where square bracket H plus is equal to concentration of H plus ions in mole per dm cube. Remember mole per dm cube? Like geometry from chemistry. Okay, maybe you don't need to know this. But basically, it's just concentration of H plus. That's the main idea. Okay? And usually it's a very, very small amount of very, very small concentration, like let's say 0.005 mole per dm cube. Okay, then in that case, let's check. If we have a concentration of H plus being 0.005, whatever units it is, then what would be the pH? pH here says you take negative log base 10 of the concentration. So it's negative log base 10 of 0.005. But that is really just, okay, of course, this negative log base 10, you can rewrite it in scientific notation as 1, 2, 3. So 5 times 10 power negative 3, right?
Yeah.
Then you can split it up. So negative log base 10, okay, I draw a square bracket here. 5 plus log base 10 of 10 power minus 3. Minus 3 bring down, you get log 10 base 10 is a 1, so it's just negative 3 here. But what is log 5 base 10? What is log 5 base 10? It's just calculator LG, right?
Yeah.
Then over here, you can just key in the value. You can have a negative in front. So what do you notice about this negative in front? You have to distribute. So that means you get what? You get negative 0.69897, then plus 3. So if let's say, let's pretend that this value is insignificant, wouldn't it mean that the main contributor to this pH would be this plus 3 here? Plus 3 minus away some decimals.
Yeah.
Maybe 2 point something. So that means that this power here is the main contributor of the pH level. And it is negative. Why is it negative? Because here is a decimal value. Then in front over here in the log formula, we have an extra minus so that we can make sure we cancel off with this minus to get a 3. So let's just simplify it straight away. This will be approximately, what would this be? Approximately 2.301 pH level. So that will be very acidic. Does that make sense?
Yeah.
pH level is 2. So it's acidic. Okay, but let's just read the question first. What they gave a description. pH value is given by the formula pH equal negative log base 10 of H plus concentration. Some plants, they may produce flowers in different colors. Then research has indicated that their color depends on the pH of the soil. It will be blue when the pH is between 5 and 5.5, purple when the pH is between 5.5 and 6, and pink at pH 6 to 6.5. So what color of flower will be produced for each of the following soil acidities? Let's look at part 1. So they tell you the soil acidity here, which really just means the square bracket H plus. It's 5.6 times 10 power negative 7 of mole per dm cube. Here they use liter, sorry. 1 liter is actually the same as 1 dm cube. Sorry, you were saying something?
Is it like you just find the minus log base 10 of the 10 minus 7, then like you can tell already.
Yeah, correct. So it's actually, if from here I see minus 7, I can roughly tell it should be a positive 7 already. But actually, I just realized something. I didn't have to go through this long-winded process. I just had to key in the calculator because I have log base 10 on the calculator. Right or not? So you just need to key in negative log of that value. So what do you get? Can you key in the calculator and tell me?
You get 6.2518.
Yeah. Okay, good. So in that case, 6.2518. Look at the scale. What color would the flower be?
Flower would be pink.
Yeah, exactly. Because it's more than 6, less than 6.5. Okay. Then part 2, do you want to try or I skip?
Won't it just be purple?
Is it purple? Let me see. Negative log, I haven't calculated yet. Negative log of 7.8 times 10 power negative 6. This is a 5.107, right? Is that what you got?
Blue.
Blue, right? Blue. Okay. Maybe this one I just write down the working. So on our calculator, log means log base 10. So because it's 5.1 something, which is more than 5 but less than 5.5, that means your flower will be blue color. Okay, according to the question. Moving on. Let's see, question 3. Question 3, we got temperature change. A liquid cools from its initial temperature to a temperature T degrees Celsius in X minutes. Given that T follows this formula, 85 multiplied by 0.96 power X, find its initial temperature. What does initial mean?
What does initial mean? So initial would just be 85.
Correct. Yes. It will imply that when initial would mean that the number of minutes from its initial temperature would be 0. No time has passed at the very beginning. So X equal to 0. If you sub in X equal to 0, you'll just get T equals to 85 times 0.96 power 0. Anything power 0 is 1. So it's just 85 times 1, it's just 85 degrees Celsius. Can? Yeah, then the value of T when X equals 15, just sub in only. This is quite simple, right? It should be just 85 times 0.96 to the power of 15. Key into the calculator and you get 46.0773. 3SF, so 46.1. Is that okay? Part 2?
Yeah.
Part 3, well, value of x when t equals 30. Here you have to be careful, you're subbing in the t, not the x. So 30 equals 85 times 0.96 power x. How to solve for x?
Divide 85 both sides.
Then you'll be left with this.
Then log base 0.96 of 30 divided by 85 equals to x.
Yes.
Then use change to base 10, then calculator.
Yes, correct. So this will be LG is log base 10 of 30 over 85 divided by LG 0.96. Key in the calculator. Oops, sorry. Just LG. This is LG 30 divided by 85 divided by LG 0.96. 25.512. Okay.
Okay.
Okay, good. That is temperature change. So how does the graph look? How does the graph look? Can you try drawing?
How does the graph look?
Yeah. Remember a power x?
This
What's my
is
a here?
less than 1.
So how does the graph look?
More than
Try
0.
sketching.
I mean, like it would be. Wait, hold up. Wait. It would be.
Yeah, exactly. Just go downwards. What point will it pass through?
When x is you when x wait.
Y-intercept, so it's 0. Is it 1?
No, it's 85.
Yes, it changes according to the coefficient here. So in general, you have y equals a e power x. It will always pass through 1 comma a. But if it's just, sorry, not e, can be any letter, any number a. That's positive. Positive little a. Can? So basically the temperature is decreasing as time passes. Oh, actually, even to be even more accurate, I shouldn't start the graph for negative values of x. Because x represents how many minutes pass after its initial temperature. So it can only be positive. You can't have negative minutes, right? Yeah, so this is the graph. Okay? Okay, good. Moving on. Question 4. Let's go. What is question 4? Population growth. So yeah, this one biologists will use this. An experimental population of fruit flies increases according to the law of exponential growth, such that after t days, the number of fruit flies n is given by this.
100.
100 times 1.65 power t. Yeah, correct. How many fruit flies are there at the beginning? Yes, just sub in t equals to 0. Then you get n equals to 100. Okay, part 2. Part 2 is saying what is the population after 4 days? So sub t with
741.
Oh, is it 741? Let me double check. 100 times 1.65 power.
200625. But 3 asset.
Yeah, okay. How about part 3? Part 3 now you sub in with
N equals to 400.
Yeah. So how do you solve this? You get 400 equals 100 times 1.65 power t divided by 100. You get 4 equals to 1.65 power t. Then you get here maybe instead of log base 1.65, how about if we write down ln on both sides?
Okay.
Then we get 1.65 power t ln 4. Then the t can bring down in front. So we get t multiplied by ln 1.65. Solving for t, we get ln 4 over ln 1.65. Of course, it's change of base can tell you this is the same as log, base 10, or just lg. lg 4 over lg 1.65. So what's the answer?
Ln answer 2.773 SF.
Yeah. Okay. Good. Okay. So how does the graph look? Sorry, it shouldn't be x and y. Sorry, it should be x and t and n. Yeah. Can you try? Yes, exactly. Just go up. The point here is 0,
0, 100.
Good. Okay, that's all. Can next. Easy. Question 5. Question 5 is radioactivity. 100 grams of radium. If you look at the periodic table. So exponential graphs are always used in chemistry and physics and biology as well, in the sciences. Okay. 100 grams of radium, Ra226. 226 is what? I think it's nucleon number.
Oh.
Nucleon means protons and neutrons. How many protons and neutrons? How to spell neutron? Cannot spell. So how radioactivity works, I believe, is there are certain elements that have like some protons and then you got some neutrons, but there are some special ones that have extra neutron. Then what happens is they fly out. They will decay. Then when they fly out, there's also extra energy given off. That's how the nuclear energy is collected. When it decays, there's extra energy released, then we collect this energy. But it's quite dangerous if not contained. Okay, so there's this, let's just read the question. You have 100 grams of this radium element, radioactive radium, and it's stored in a container. The amount of radium R represented after T years is given by this formula. Capital R equals to 100 times e to the power of negative 0.000427 T. So this is a very, very small number because if you have too much of this amount of radium, it's gonna cause a huge disaster. Cannot have too much, all right? So how much of the 100 grams of radium would remain after 10,000 years? 10,000 years means what? T equals 10,000.
Okay.
Then R equals 100 times e to the power of negative 0.0004279 times 10,000. Can you key this in the calculator for me?
It is 1.393 SF.
Yes, 1.39 grams. Okay, good. Okay, part 2. How long will it take before the amount of radium is halved? So what's the initial amount of radium?
100.
Yes. Sub T equals 0, you get R equals to 100. This is initial mass. So when you halve it, what happens?
R becomes 50.
Divide by 2, 50. So you sub R equals to 50 into the formula. Okay, I don't even bother saying into anymore. Just say sub R equals to 50, and then you get 50 equals to 100 e power something something. Then you solve for t.
Yeah.
Okay, solve for t. 50 over 100, half. Equals to e power something. Then what kind of ln should you take? Sorry, what kind of log base should you take?
Ln.
Ln, yes. just take base E because you already see a E. So refill the answer. Okay, ln half equals to ln E power whatever. Then ln and E cancel each other off. You're just left with the power. I mean, technically should be the power bring down because of the power rule for logarithms. Then you multiply it by ln of E.
Mhm.
But then ln of E is 1. So we take whatever is in front, multiply by 1. You're just left with whatever is in front without the 1. That's ln half. Then you solve for t. So just divide 1 over negative blah blah blah. Multiply by ln half. What is that value? Type in the calculator for me.
It's 1619.881235.
3SF then will be 1620. Okay, so this is what we call the half-life.
Half-life.
Half-life. Like at first you start with 100, you drop to half of it, 50. This is how long it takes. Half-life from 100 grams. Yeah. Okay, moving on. Okay, there's links to differential equation. Separable differential equation. This is a H2 math topic. But you don't need to know it. Okay, moving on. Let's see question 6. Light intensity. Okay, so one of the SI units I think for measuring light intensity is like what, lumen or something. But I think that's what this question is talking about. But I don't know much about physics, so don't ask me. I just follow the question. Okay, let's take a look at question 6. Light intensity. Each millimeter thickness of a translucent material reduces the intensity of a light beam passing through it by 13%, so that the intensity I of the light is given by I equals to 0.87 T. Where did this 0.87 come from? It came from 100% minus 13% equals to 0.87. Oh, sorry, 87%. Right? Which is 8% means divide by 100, so it's 0.87. That's how they get 0.87 here. Okay?
Okay.
And then raised to the power of T, where T millimeters is the thickness of the material. Okay, so basically the graph looks like this. I here, T there. The more thick it is, the lower the intensity of the light. It just keeps decreasing. Okay, technically the thickness cannot be negative, right? So it should be like this. Okay, that's how the graph looks. Then again, part 1, what is the initial? Find the, oh, sorry, they never asked the initial, sorry. Find the intensity when the thickness is 1.5.
Sub T equals to 1.5.
Then I.
0.811.
Oh, I haven't calculated yet. Let me see. 811 is it? Let me see. Correct. Yes, 0.81148197776. Yeah, okay. Can part 2? Thickness of the material needed to have an intensity of 0.5. Sub.
Sub I equals to the number.
Yeah, 0.5. So
Yeah.
so it should be 0.5 equals to 0.87 power T. How to solve?
Log 0.5 divided by log 0.87.
Yep. Base what? 10?
Yeah, sure.
Okay.
4.983 SF.
Okay, good. Let me just sort the order around so it looks nicer. 97728. Yeah, 3SF is 4.98. Okay, good. 4.98. This is T for thickness. Sorry, it should be capital T. Be consistent. Millimeters. Okay, question 6 done. Let's look at the next one. Okay. Question 7. Let's see. Question 7. We have on the same axis, sketch the graph of y equal LGX and ln x. Okay, let's see. Try to be a bit more accurate here. So we got, let's say this is y equals LGX log x base 10. Then now you have the other guy, which is y equals to ln of x, which is log x base e. They will both pass through 1, 0. But for ln, because it's base e, right? Base e is smaller than base 10. So what does it mean? Who will decrease slower? Very simple. Confused, right? You know that they both pass through here, so it's either like this or like this, right?
Yeah.
Then let's just draw a line here. Let's call this x equal to 2. Then we check both of their value. So when x is equal to 2, let me just write down some working here. Lg of 2 is equal to something. Ln of 2 equals something. What is it? Check with a calculator.
The ln is higher, so it'll be like this, like
do you draw something?
like,
yes. And then the left half continue down like this. Oh, okay. Yes, good. Okay, yeah, then that's part 1. Part 2, use the graph to find the range of values of x for which LGX more than 0. For part A. LGX more than 0. So what does it mean? You look at this graph, you look at the part of the graph that is more than 0, means you focus on the y coordinates. So which part is more than 0? Can you highlight for me? Which part of the graph should I be looking at?
you should be looking at where should you be looking at?
Don't know. Okay, so basically, right, every point on LGX graph could be like, for example, 5, LG5. This could be 4, LG4. So in general, right, all the y coordinates are your LG values. Right? Here, when we say LGX more than 0, we are focusing on the y coordinate of the LGX graph. Then in this case, when we say LGX more than 0, it means your y coordinate is more than 0. So which part of the graph have y coordinates being more than 0? It must be the part that is above the x-axis, this part here. Does that make sense?
Yeah.
From here onwards, you will get negative. So it doesn't satisfy this condition. Over here, it's also equal to 0. So this guy should be focusing on this guy. Empty circle. Empty circle means I don't include that point. Because if I include that point, I'll get LG of 1, which is a 0. This guy here. And we don't want that. We want the LGX that's more than 0. So from there, can you tell me what's the solution for x? How do you get this graph? You need to restrict the x to be starting from 1 and you go to the right. So it's x more than 1. Does that make sense?
Okay. Yeah.
Here is 1 and then you go to the right. But do you include 1? Do you need to put equal? If x equals to 1, what's LG of 1? It's 0. Is it more than 0? No. So we don't put the 1. Don't include 1. Okay. Part B, let's try. Part B is asking, find the values of x such that, find an inequality for x such that LG of x is less than or equal to 0. What would that be? Just now we consider more than 0, so on top, right? the top part more than above the x-axis.
So just
Then
the
now,
x less
just the-
than 1.
so this
Less than or equal to 1.
yes, correct. And then maybe I can draw a solid circle here. Solid circle means I include a point. Empty circle means I exclude. So yeah, x less than or equal 1. How about part C? lnx more than lgx. So lnx more than lgx means what? You want the part of the graph where the ln is above the lg. So which part? Can you highlight for me?
Wait, like.
Oh, sorry, I realized I highlight wrongly. The purple should be this part here. Oops. lnx more than lgx means you want this lnx graph to be above the lgx graph. Which
Like
part
this.
will it be more? Ah, exactly. Correct. It's only this part, right?
Yeah.
So only this part. So what's your solution for x? X. How do you get this part of the graph? You need to restrict the x to be from
More than 1.
more than 1. Yes. Good. Okay. Understand this idea? You can use the graph to solve the inequality. Okay. Good. This is actually almost a A-level H2 math topic already. H1 also. Using the graph to deduce the solution to inequality. Okay, moving on. Question 8. Question 8. Investment. Yeah. So this is the compound interest I was talking about. So let's read the question first. If $5,000 is invested in an account that pays 4% interest, let me list down the information. 4% interest compounded annually. So PA. The amount $8 at the end of T years will be given by the following formula. A equals 5,000 multiplied by 1 plus 4% over T. They simplified it down for you as 1.04 power T. Okay. Then what would be the amount at the end of 5 years? Sub T equal to 5. Yeah, then you get A equals to 5,000 times 1.04 power 5. Okay, I'll leave that to you to work it out. How about part 2? At the end of how many years would the amount first exceed 8,000? Amount is A, exceed is more than 8,000. Yes, you can also sub A equal to 8,000 to solve it straight away to get the T. Let's see what we get. 8,000 equals to 5,000 times whatever. Divide by 5,000. Actually, I can cancel off 1,000 on both sides. So I get 8 over 5 equals to 1.04 to the power of T. Then I can take ln 8 over 5 over ln 1.04 equals to T. So what's that?
That would be 11.983.
If you round off 3SF is 8 up or down? 12.0, yes. Good. Okay, so actually, here they're asking how many years. So 11.9 will mean you hit 11.983 years will mean that you exactly hit your $8,000. And since this is compounded annually, right, it means that by the end of 11 years, you haven't reached the amount. But by the end of 12 years, you will hit the amount. So the answer is just 12. Okay, when you exceed 8,000. So the answer is 12.
Okay.
11 too little, 12 is overshot. 11.98 is just nice, but you cannot take out, they will not compound for you when you take 0.98 when you put in for 0.983% of a year. Fraction of a year. Okay, so anyways, part 3, express T in logarithmic form. They're asking you to solve for t. How to solve for t?
Wait, in terms of A.
Yes.
Oh, okay. A divided by 5,000. Then wait, how nice does it have to look?
They didn't specify, so it doesn't matter.
Okay, yeah, no, then ln A over 5,000 divided by ln 1.04.
Yep, that's it. Okay. Don't need to clean up. It's fine. This is good enough. Okay, next one. Question. Yeah, maybe I should leave some as homework already. Okay, I'm gonna skip 9 and 10. That's gonna be homework. Okay, next one, advanced. Let's look at question 11. So we got 4 and 6. So at 6:45 a.m., a coroner was called to the home of a man who has died during the night. In order to estimate the time of death, the coroner took the man's temperature twice. Murder mystery. 7 a.m., you have a temperature of 28.8 degrees Celsius. The dead body, is it? Then 7:29 a.m., the temperature, the dead man's temperature is 28.0 degrees Celsius. So from these two temperature readings, the coroner was able to determine that the time elapsed since death and the body temperature were related by the formula T equals to negative 2.35 ln T minus 24.5 over 12.4, where T, little t, is the time in hours that has elapsed since the man died, and capital T is the temperature in degrees Celsius of the man's body since death. Assume the man had a normal body temperature of 36.9 degrees Celsius at death, and the room temperature was a constant 24.5 degrees Celsius. Use this formula to estimate the time of death of the man. Oh, interesting or not?
No.
No? So sad. Okay. So basically you got this formula. Little t here is the time since death, or duration since death, number of hours. And then you got a capital T here, which is, what is it? The temperature of the man's body. Okay. Yeah, this one is about the temperature of bodies. This is actually quite common in exponentials or logarithm questions. So they tell you that the man had a normal body temperature of 36.9 degrees Celsius at death. And the room temperature was a constant 24.5 degrees Celsius. So how do you estimate the time of death of the man?
Sub T equals 36.9.
Exactly, that's all right. They give you a lot of nonsense, but all you need is to substitute this capital T with 36.9. Then you can solve for T already. But wait, actually you need the exact time of death, right? Here, little t, after you solve, you'll get the duration. So you still need to draw a timeline, right? You work by words. Do you get what I'm saying? Do you understand? Okay, wait, we just...
Wait, like what do you mean?
Like here, look at the little t. It's telling you the duration in hours since the time of death. Right?
Oh, yeah, okay.
So you still need to work by words after you solve for little t.
Oh, yeah. Like add to the time.
Yep. Work by words. Yeah. So 36.9. Let's just calculate that. Negative 2.35 multiplied by ln of a fraction, 36.9 minus 24.5 over 12.4. Hey, it's a 0. Hey, it's a 0. Is that right? Do you get 0?
Uh-huh.
How? Why is it 0? Let me see. So that means 0 hours passed. That makes sense, because 36.9. When is it 36.9? When the man is still alive, right? So t equals 0 makes sense. You haven't died yet. You get what I'm saying?
Okay. So it's
Yeah,
not
so-
dead.
No. He is dead. It's just that this formula is very generic. So it accounts for the case where he is still alive. When you sub in capital T equals 3.69, you will get to little t equal to 0. So what is the interpretation? It means the 0 hours have passed since he died. So he is still alive, or at least at the point where he just died. It's 36.9. Then once he died, he start to decrease temperature. Then the T start to increase. Okay? Can?
Okay.
But so that's why, actually this question is still a bit more difficult. You need to use the information from the question. So let's read the first part. They tell you 6:45 a.m. blah blah blah. He traveled there. Coroner reached a place. Then he took the man's temperature twice. From there, that's the key point. 7 a.m. temperature 28.8. 7:29 a.m. 28.0. So how do we use this formula? We actually need to use the information here and here. So yeah, let's see. How would this graph look actually? How would this graph look? It will actually look something like ln means what? Ln means it looks something like this, right? If this is y equal lnx. I change to t. Instead of y, I change it to little t. Right? If this is ln of t, this is how the graph looks. But here you got a minus 24.5 and divide by 12.4. Actually, it just shifts the graph a bit to the right. Okay. And this divide by 12.4 actually just scales it down. Scales it by a 12.4 factor. You stretch it out by 12.4. Let me show you. I think it's better if I don't draw it myself. I'll just use Desmos. Use the graphing software, then you can see better. Can you see? This is LNX. Let me just change the scale a little bit. Maybe I'll change to 20. Okay, that's not good. Let's see. Maybe I will change the X scale down to just 10. Okay, close enough. Oh my goodness. Sorry, let me get my computer to load first. It just hanged on me. Sorry. Could you give me a bit of time?
Okay.
Hi, I'm back. Is it loading the screen? Can off. Okay, let's draw the next graph. So this is lnx. What happens if I change the lnx inside by introducing let's say I just divide by 1 first. Then x I minus away 24.5. Let's see where this graph is. Cannot see the graph. Okay, I need to zoom out. Zoom out. What happened? What happened to the graph? Can you see what happened? It just moved to the right. When you minus 24.5, it moves to the right. Minus will make it move right. Plus will make it move left. But then that's not all. This graph actually has a divide by something. Divide by 12.4. So what happens? Let's draw another graph. Divide by 12.4. So essentially what happens is that it gets stretched by 12.4. Okay, I know it might not be so obvious here.
Yeah.
Maybe if I just put in like y equals 1, you can see. Here is 27. The purple and black graph. Can you see that it goes from 27.218 to 58.207?
Okay.
What happens if you divide them? 58.207 divided by 27.218.
Wait.
Oh, actually, that's not very accurate. Let me think a bit. All right, this divide by 12.4 applies to the 34.5 as well. Okay, got it. Let me do it step by step. So let's say that now I have ln x minus away 24.5 divided by 12.4. Okay, this is getting quite messy, but I'll just hide the graph. That's irrelevant. Okay, this is the current graph. Can you see? This blue graph. Okay, now if I purposely introduce an extra divide by 12.4 to the x, then I can add the fraction together, then that's the resulting graph. What happens is that this graph gets stretched by a scale factor of 12.4. Okay, this x minus 24.5 over 12.4 is actually equivalent to x over 12.4 minus the same constant 24.5 over 12.4. So what happens here is that the graph gets stretched. So let's see if I draw a y equals to 1, can you see? Y equals to 1. Maybe my y-axis, I'll just change it to 0 to, let's say 6. Okay, something like this. I think it looks more clear now. Can you see that they intersect at 4.694 and 58.207? Then you divide those two numbers. What do you get?
Do you get 12.4?
Yeah, you get 12.4. So what happens is that the graph gets stretched by 12.4. When the x, you see, before in the blue graph, it was just a single x. But then the resulting black graph, you just take the x, you divide by 12.4. The graph gets stretched by 12.4 times. The 4.694 times 12.4 becomes 58.207. And likewise for all the other points. You can try another point, like let's say y equal 2.7. It cuts the graph at 209.009 as well as 16.856. Again, you'll realize that it's just a scaling by 12.4. Right, 16.856 you multiply by 12.4, you'll get to the 209. Yes? Okay, so that's how the resulting graph looks, but not enough. The actual graph still has a negative in front, right? There's a, what is it? Let me see, negative 2.35. So actually, the black graph is not enough. We still need a copy and paste negative 2.35. Okay, so this is the resulting graph. This is how the graph looks. Can?
Okay.
Then let me just copy it down. It intersects the x-axis at 36.9. Okay, let me change back to my screen now. Okay, so this is how the graph looks now. How do we interpret this? We already found out, we already have information about the 7 a.m. is 28.8 degrees, 7:29 is 28 degrees Celsius. So what this means is, what we are really doing is, we are trying to figure out when this temperature here, this is capital, oh, sorry, let me think a bit. This is T here and this is capital T, right? So what we are trying to do here is capital T, we're substituting with Oh, maybe if I just make the graph a bit nicer. Hold on a second. Something that looks like this. What we are trying to do here is we should actually substitute in with the 28.0 here and the 28.8 here. Then we get the corresponding t value. E equals question mark, t equals question mark. Do you understand what I'm doing here?
Okay.
Then from there, we can work backwards to figure out the temperature. Let's just substitute in those two values first. So this t equals to 36.9 is not that useful. Let's shrink it down and toss it aside. Instead, we sub in with capital T equals to 28.0. Then we see the little t. What do we get? .9725. Okay. Can? Then you do the same thing, but now with 28.8. So the exact same working, but change the 0.0 to 0.8. Change the 0.0 to 0.8. Change this value here. What would it be? 28.8. You get to 2.488. So this little t is what again? Number of hours, right? Yeah. So how do you tell what is the actually I just realized you actually don't need this information. You just need this information can already. Let's draw a timeline. Here is 7 a.m. Here is 8 a.m. What's the corresponding temperatures? This was let me see again. I can't remember. 28 degrees Celsius is 7:29 a.m. 29, sorry. This is 28.8. Then what did they tell us about from this 28.0 degrees Celsius? They tell us that how much time has passed? 2.9725 hours has passed. How about the other guy? 2.4888 hours has passed. That makes sense, because when you go from 0.4888 to 0.9725, that's how many hours? It's 2.9725 minus away 2.4888, which is 0. What is it? I need a calculator for this. .4837 hours. In terms of minutes, if you times 60, this is 29 minutes, which makes sense. 7 a.m. to 7:29. So what's the original time of death? The original time of death is somewhere before the inspector arrived, 6:45 a.m. sometime before, and the temperature is while he's still alive, 36.9 degrees Celsius. We found out that this will be 0 hours. This wasn't useful to us. But we already know this is 2.488 hours. Can we work backwards to find out the time of death? Alternatively, we also know 2.9725 hours. Can we work backwards to find out the time of death? Can. Let's convert these into hours and minutes. Let me show you how to do it using a calculator. Have you recorded down these two values? Can 2.488 and 2.9725. Let me show you my calculator and how to use a calculator to help you. Okay, so press on. Then go to 2.4888. Then you just press this button. This button is calculating in base 60. So how many hours, how many minutes? 0 hour. This, if you press it one time, it means 2.488 hours. You press enter, they will automatically convert it into hours and minutes for you. 2 hours, 29 minutes, 19.68 seconds.
Okay.
Okay. Yeah. If you want to do it manually, you have to get rid of the whole number, 0.488. Then you multiply by 60. That will be the number of minutes, 29.328 minutes. Then you get rid of the whole number part, 0.328. That's the number of minutes, but you times 60 to get number of seconds, which is 19.68 seconds. 19.68, 29. That's how you get 2 hours, 29 minutes, 19.68 seconds. Okay. Let me just record this down. I'll show you later. Then for the other value, it's 2.9725. Sorry, I forgot to put the hours. Convert it into hours and minutes. It's actually 2 hours, 58 minutes, 21 seconds. Okay. Then now I change back to my iPad. Hold on a second. Oh. Okay, good. So we already recorded the duration, 2 hours, 29 minutes, 2 hours, 58 minutes. So what's the original time? 7 a.m., 2 hours, 29 minutes has already passed. Work backwards, you have to subtract 2 hours. So maybe it's 5 a.m. Then minus 29 minutes. So 4 a.m. what time?
31.
Yeah, exactly, 4:31. Okay. You can also do the same thing out, 7:29. Take away 2 hours, 58 minutes. Okay. Time of death. Oh. Okay, good. Okay. Do I have time for another question? That was advanced. Maybe I'll leave question 12 and 13 for you to try. I'll also give you some extra homework. Yeah. Question 14. Okay lah. Actually, I'll just leave that to you. Do you want me to go through another question with you?
I'm okay with anything.
Okay, let me see. What have I not assigned as homework? Have you done log 1.4?
Or
So I think so far I've been assigning you homework from the log 1.1. 1.3, 1.4, have you gone through? Can't remember. Let me search your homework. What did I assign you as homework? Okay, I think I haven't. Okay. Then in that case, let me just send you a message on the. Wait, what? Where's your chat? I just send you a message on the Telegram. So you can just go back to the album and find the log 1.3 and 1.4, I guess. Does that, have you done it already? Does it look familiar to you? Maybe you have, right? 1.3, 1.4? No?
wait. Section?
Yes, yes. I think you does. Okay. Sorry. Then what should be the homework? Let me see. Maybe the log 2. Yeah. You should do the log 2. Yes. Yes. Log 2 and the log 3. Is it okay if I give both as homework? Is it too much?
Okay.
Can I log 2, log 3? And then still got log homework 1 and homework 2. Should I give that as homework? Is it too much?
I mean, I'll just do what I can.
Okay, yeah. Because you can do all the questions already by now. Can I just say do all? Okay, yeah, so you do the log 2 and the log 3 as homework, I think. So here, log 2 and a log 3. You can look at the answer if you want. Just try yourself first. Okay, then that's all for today, I guess. Is that okay?
Okay.
Can I? Yeah, then that's all for today. Okay, bye.
Okay, bye. Okay.
All right. I'll send you the homework later.
Okay. Thanks.